There we are.
Hey, here we are.
Hey there, hi there, ho there. You pick up your nose, Mike?
What's that? Gotta blow some air in there. Get a little foggy.
Okay, hey, good evening, everybody, and welcome back to our Sunday night offering of Astronomy Edutainment, the Sunday Night Astronomy Show. Hey! Hi, my name is Chris Kerwin. I'm the creator of the social media channels known as Astronomy by the Bay. I'm also an amateur astronomer and a member of Raskin and Brunswick. Hey! First of all, I'd like to welcome back my two regular co-hosts, Mr. Paul Owen from the Moonshadow Observatory in beautiful Hampton. Hey, Paul.
Hello.
And Mr. Mike Powell from the PFO Observatory here in St. John. Mike, good evening, sir. All right, going to be one of them nights. Okay, on tonight's episode of the Sunday Night Astronomy Show, comets are often described as dirty snowballs because they are cosmic bodies composed of frozen gases, rock, and dust. Now, they are essentially leftovers from the formation of the solar system 4.6 billion years ago, and can provide clues about its early conditions. Two comets have made their appearance in our evening sky now, Comet C2025A6 Lemon and Comet C2025 R2 Swan. What do we know about these comets in general? What do we know about comets in general, and specifically these two comets? Will they be naked eye targets? When is the best viewing going to be? We'll answer these questions and discuss more about what's happening in October tonight. Also tonight, Final Bud. Hey, whether you like it or not, Final Bud will be back with his 5 binocular target of the week. Yep. Paul will deliver another interesting Rosanna's fun fact.
I will.
You will. I'm going to offer. I'm not going to offer a view of what's up because we're going to be talking about that first up anyway. And I'll have your wonderful photo submissions to share. So sit back and enjoy, everybody. And remember, this is a family-friendly, live, interactive broadcast. So let's get started then. Look at comets, especially the two in our evening sky for this month. So that's me, and I have to find you first of all.
Big belly bud. That works good.
Huh?
Big belly bud.
Hang on. Right over here. Okay, so there's a presentation. I just got to get it on the right window. So from beginning, should be there. Minimize this one. Put that left double, and let's choose my right screen. Share.
You zig type.
Sometimes.
Sometimes it's loose. Loose.
Okay. Yeah, 1 second. I'm going to go back to our Google Meets call, and there we are. And I'm going to say show my screen anyway, so you can see that. Okay.
It looks good.
Good. Okay. All right. Comets are solar system's dirty snowballs. So what are comets? First of all, comets are large icy bodies composed of dust, rock, and frozen gases that orbit the sun. They are essentially remnants of the formation of the solar system about 4.6 billion years ago. Now, as a comet nears the sun, it heats up, causing its ice to vaporize and release gases and dust, creating a glowing coma, a large atmosphere basically, and often a visible tail that can stretch for millions of kilometers. Comets are often called dirty snowballs because they are made of ice and dust along with frozen gases like carbon monoxide and carbon dioxide, and they follow orbits around the sun that are often highly elliptical, meaning they can take them from the outer reaches of the solar system to the inner solar system. Now, the distinctive tail is created when the sun's heat turns the comet's ice directly into gas, a process what we call sublimation. Now, the solar wind and radiation push this gas and dust away from the sun, forming the tail. Many comets come from two main regions in the outer solar system, the Kuiper Belt and the Oort cloud. Now, the Kuiper Belt is a donut-shaped region of icy bodies beyond the orbit of Neptune, located from about 30 to 50 astronomical units from the sun. It is a large, cold, and dark area containing leftovers from the solar system's formation, including dwarf planets like Pluto, comets, and millions of smaller icy objects. Now, the Oort cloud is actually a hypothetical spherical shell of icy objects that surround our solar system, located far beyond the Kuiper Belt. It is theorized to be the source of long-period comets and is estimated to contain trillions of icy bodies. That's a hard number to put in your head. What about a comet, though? Okay, anatomy of a comet. Well, the comet has 4 visible parts. Actually, 3 of them are visible and 1 isn't. We'll go with the nucleus, coma, the ion tail, and dust tail. However, there is invisible regions too. The nucleus is the solid core of the comet, often described as a dirty snowball. It is the mixture of frozen gases like water, ammonia, carbon dioxide, and methane, dust, and rocky material. Now, the nucleus is the most central and the smallest part, typically just a few kilometers across. The coma is the atmosphere that escapes from the nucleus. As the comet nears the sun, the solar wind sublimates the volatile ice into vapor, carrying some of the dust particles along. A coma color changes according to seasons on a comet. As a comet nears the sun, its coma sometimes glows green. When a coma is green, it is because ultraviolet light excites electrons in the cyanide and cyanogen and diatomic carbon, which emit green light as the electrons return to their lower energy state. A comet has a coma, while an asteroid lacks this feature. Come on by one. Here we are. Comets do have 2 main types of tails that form from the coma. An ion or a gas tail, created as solar UVA radiation ionizes the gas from the coma. Now, the solar wind then pushes these charged ions away from the sun, causing this tail to be straight and often bluish. And it has a dust tail. It's formed by some of the dust particles released from the nucleus. Solar radiation pressure pushes these dust particles away from the coma, creating a long, curved, white or yellowish tail. The distinctive tail is created when the sun's heat turns the comet's ice directly into gas, a process called sublimation. And finally, the hydrogen envelope is an invisible cloud of hydrogen surrounding the coma. Now, the hydrogen cloud that surrounds a coma can be millions of kilometers in diameter, but the neutral hydrogen gas only appears to instruments and not to our human eyes. So these are the parts of the coma. We get to see them, almost all of them. Anyway, okay, so from there, let's step ahead to what about our evening comets. So this is the October show, we're calling it right now. These are values I took today off of Heavens Above website. So comet C2025R2 Swan is at its closest approach to Earth on October the 20th. And its magnitude 5.4 they're saying right now as of October 12th. So that's just outside the range of visible naked eye. Mike might argue that one, or I've seen some posts that were saying it was up to 9, but the majority that I watched today said it was right around 5.
What I saw was the closest, the brightest it's been observed so far was 5. And when I took a photo the other night, it was 7.
Of R2? Of Swan?
No, of Lemon.
Of Lemon, yeah, okay. So yeah, I think it's, the numbers are a little bit, how they come up with that number 5.4 instead of 5.5 anyways, pretty tough to me. But
Well, like I said, when I saw it, it was the brightest recorded magnitude. Now, that could have been down in Australia where a lot brighter, right?
That's right, yeah. Anyway, they're very close to naked eye, both of them right now. And you can capture them with, and I'll get some pictures here tonight. Some people have used sea stars to capture them, and long exposure DSLR pictures as well. So they are a binocular target. Small fuzzball so far in a binocular target, but we're holding on to these dates because now also A6 Lemon is going to have its closest approach on October 21st. So they're both within a day of each other, and it's magnitude 5.7 right now. Now the good thing about this too is that the new moon comes on October the 21st, which is perfect, right? So we want a nice dark sky. We're going to have a nice dark sky for sure. And the Orion meteor shower peaks on the same morning of October 21st. So let's go ahead now and look at what we got. So Comet Swan, first of all, Comet C2025R2 Swan is a long period comet discovered back in September, just not long ago, just a month ago. And it's known for its beautiful long gas tail and unpredictable brightness. It is a once in a lifetime event as its orbital period is over 22,000 years. Well, I might be here for the next one. You guys know?
What's that? Who?
Actually, I might be
Maybe.
here for the next one. Maybe, you never know. The
Maybe.
comet was brightest around mid-October. It said it's supposed to be. No, that should be. It will be brightest around mid-October when it's closest to Earth, and can be
Yeah.
observed with binoculars in the southwestern sky just after sunset right now. And where can we find it? Well, here's a nice little map I got from Scott Young, our friend out at the Manitoba Museum. So here's Comet Swan in our evening sky. So here it is on the 8th, 10th, 12th. So here we are right now, and we're just underneath Ophiuchus in our western part of our sky. So if you have
So it's
stellar,
gonna,
there's Sagittarius right there. So that's right in the center.
Yeah.
That's the south, right? Southwest, I guess,
yeah,
right now.
yeah.
So it's going to be on the 18th. It'll be right over the teapot.
Well, the
Right.
teapot and now, but each night that passes, that teapot's getting lower into the horizon. So
It
Yeah.
is, yeah, yeah.
comet's not going to be really high, probably even at its peak.
Well, there's 10 degrees. They said fist held at arm's length. So I don't know. That might be 20 degrees, maybe on the
Yeah, it
18th.
probably looks about 20 or a little bit
Right
more.
now it's less than 10 probably. And it's not supposed to be the better one of the two anyway, but it is the fact that we do have two in our evening sky right now.
Yeah.
So that's the target to take a look at. He says view at 6:30 p.m. Central Time, which would be about 8:30 for us, I guess. Go ahead a little bit farther to Comet Lemon. This is the actual GIF or a video of somebody captured it. Comet Lemon C2025A6 was discovered on January the 3rd, 2025 by the Mount Lemmon survey in Arizona. It is a long period comet with an orbital period of about 1,350 years, making it closest approach to Earth on October 21st, and its closest point to the Sun on November the 8th. Though it may be visible to naked eye under dark rural skies, though binoculars are more likely to be required, its brightness is notoriously difficult to predict, as all comets really are, but it's expected to be visible in the pre-dawn sky and the post-sunset sky, so it is available in the morning sky and evening sky right now. It is visible in the constellation of Ursa Major, which is nice because everybody knows where the Big Dipper is, so that gives you a nice high. Well, it's not a high point in the evening, but it's a familiar spot. With a magnitude of about 5.6 as of October 12th. So binoculars are recommended for viewing right now, and its next appearance won't occur for another 1,150 years, around the year 3180. Might come back for that one. Okay, here we are. So here's Comet Lemon in our morning sky, and it's in our morning sky. Somebody emailed me earlier, said, why is it going from northeast to northwest? And we're seeing it we're seeing it both morning and night, and that's because of the location of it. Because here's the Ursa Major, and it's really circumpolar, right? So, or just about. This is our morning sky, so it's nice and high in the morning. Here's our dates: October 3rd, 5th, 7th, 9th, 11th. We're right around here. So here's our morning sky, and this is about 5 a.m. Central Time. So for us, about 7 a.m., but I think it might be a little bit earlier than that even. So, Big Dipper is a nice target, or a nice symbol, I guess, or asterism to help find your way. And it's going to be following the Big Dipper around as it makes its loop around in the evening. So let's take a look at what it's going to look at there. Here's our evening shot. So here's Ursa Major again. So Ursa Major has now, twisted from this view to this view in the evening. It's still quite a ways above the horizon. So here we are on the 12th, and this is 7 p.m. local time. So I guess 7 p.m. for us is same thing. So so here's the path it's going to take anyway, up through Booty. So it's going to be in our evening sky for at least till the end of the month. And here's the date when it should be around its brightest. So it should be nice and high. There's Arcturus as a nice marker as well. These are taken. These are taken from Stellarium. So if you have the program called Stellarium, or look it up and find it, it's a freeware program, very powerful, and you can plug in. Once you download the Comets listing, then you can look for Comet Lemon, and it'll tell you exactly where it's going to be each night, and as well as with our two Swan. So a couple of comets to keep an eye out for. Like, this isn't happening really until next week, not this week coming up, which is great, because this week coming up looks like it's pretty poor for us locally, cloudy. And hopefully it's not going to have this big outburst this week coming up and not the following week. But it's the following week that we'll have the new moon, we'll have the Orion meteor shower, we're going to have the comets at their brightest, or at their closest approach, which should be that they're at their brightest as well. Okay, so here we are. So close approach on October 20th and 21st. The new moon is going to happen on the morning of the October 21st, and the Orion its peak on the morning of 21st. So that's about 20 meters per hour. So on a dark sky, which we're going to have. So you want to find yourself a dark spot, get out to a dark spot around the new moon date, and try for all three of those targets. And unfortunately, this is our outlook for the next week. So, of course, there's a couple of celestial events coming up, right? So, but this can change, as we know.
Well, even if it changes, even for an hour, if you get a hole in the clouds in that area of the sky.
Yeah. So, all right.
Yeah, exactly. So, Chris, so you talk about these being long comets.
Yeah.
So there's short period and long period comets. So maybe you can tell everybody what those are.
Short period comet is a comet that is, I don't know how many years it is underneath. Is it,
20.
it's, what?
Every 20 years.
Every 20 years.
20 years or...
You go ahead. You get the notes up.
No, that's it. That's it. Because both of these comets are long period comets. So they're not... We'll see them once in a lifetime, I guess you could say that.
I got to stop for a second.
Yeah.
I got it.
Oh, nice.
And Mark said there's a ticking noise in the background. I just put the clock up the other night, so yeah.
Yeah. If you turn on
that's
your
for Mike.
noise reduction, you'll get rid of that tick.
We'll set it down out of the way there for now. I can look
Anyway.
up.
So long period comet is it's in the order of 200 years or more, and the short periods are 2 or 20 years thereabouts, and that's why they're predictable. The long period ones, well, I guess they are all predictable to a degree, but the short period ones are the ones that we see coming around more than once in our lifetime.
Yeah. Right.
So
The other thing is, we're used to saying there's two tails possibly in a comet. There isn't. There's actually 4 tails to a comet. The other 2 tails, besides the ion tail and the dust tail, one is the sodium tail that they have now found on bright comets.
Yeah.
And it shows as an orange color. And then the other one is the anti-tail.
Yeah.
that goes the other way.
Photograph code points, the opposite.
Yeah, we just had one of those.
Yeah. So
Yep.
kind of cool that, not just one tail or 2 tails before.
Mm.
Yeah. Yeah.
Well, fingers crossed, guys, for a good show coming up.
Yeah.
We'll see how it goes. We got another. Hopefully we've got another week before they. I mean, we know it's another week before they get the closest approach. So we're actually it's the 20th, so we're actually almost 10 days away. So
Yeah.
so we'll have an opportunity hopefully down the road. But for now, for
They're
those who are.
they're always interesting because if you want to take pictures of them, you have lots of time to kind of figure out, a really nice foreground if you want. You got all day long to find one. Just got to have your compass with you so you know where. And that's
I'm just happy to get a picture of one.
Huh?
Just happy to get any picture of one.
Yeah,
Foreground,
right.
background, just give me a picture.
Anyway, there's we were fortunate to have that with the glass comet that had the anti-tail on it, because a lot of people got it over top of whatever mountains or whatever.
That was
It
pretty
was
cool.
really quite nice.
Yeah. Well, fingers crossed for another good show. I mean,
Yeah.
one of them just popped up in September, so I mean, they're watching the sky all the time now, right? With lots of instruments, so we're gonna get a lot more. Dan says, I'm headed to a star party near Death Valley, California this week. Hope for clear skies and views of the comets. Hey, great, Dan.
Right
Oh,
on.
nice.
Yeah, so if you get some pictures, send them in to us.
Yeah.
Like to see them. Okay,
Wow.
and hello, Aaron, from Hall Beach, Nunavut. Welcome.
Yes.
Good evening from London, Ontario. Clear again. Go Jays. Here we go, Chris.
Oh, geez.
Okay.
Oh, and happy Thanksgiving, everybody.
Yeah, and happy Thanksgiving. Well, it's tomorrow, but happy Thanksgiving anyway. Yeah.
Oh, stuff. Yeah. We're not on tomorrow.
No, we're not. Okay, that's our bit of chat about that. Let's keep our fingers crossed for everybody. And I do have a few photos to show here tonight. But anyway, let's go on with a Bino Bud.
Binocular target of the week. Where's my window? This one. So, beer belly binocular target of the week this week is, see, you can tell,
Yeah, look at that.
the golf putter. I tried to have a picture of the moon in there for the ball, but it didn't quite work. So, the asterism, the golf putter and ball are located in Andromeda. It contains a straight line of stars forming the club's shaft and two bright stars perpendicular to the shaft forming the club's head. And the open cluster NGC 752 forms a ball that looks like you're about to hit with the putter. It's actually kind of cool. How do I find it in the sky? Well, tonight it's clear, semi. You go out at 9 o'clock, orient yourself at 75 degrees east northeast, look up, and you'll see the Andromeda Galaxy. And you know how we always find our Andromeda constellation and how we find the Andromeda Galaxy. We go 1, 2 stars and up 2 stars. Well, just come over 1, 2, 3 stars and come straight down, and you'll find the golf putter. Again, those are the last 2 stars. If you went 1, 2, 3 stars, come across and pretty much straight down, you're going to find the golf putter right here. There's the shaft and a little end coming out. What will you see? There's that line of stars coming down, comes across for the putter end, and then there's a little tiny cluster of stars in here that looks like a ball when you look through by our binoculars. And 10 by 50s is a good size. Again, nice straight shaft. And there's that cluster of stars that acts like a ball, so that's why they call it the golf putter. Compared to the full moon, she's got to be at least 3 full moons across, if not almost 4. So it's easy, nice big target, easy to see. And hopefully, you get a chance to get out there and look up and see if you can find yourself a golf putter. What happened to the alien that stepped in the gum? They got stuck in orbit.
Oh.
I like this one though. This is how astronomers settle their differences. It's binocular target of the week. Stuff.
Thanks,
that's
Mike.
hilarious.
Thanks, Mike.
Yeah,
Unbelievable.
Bino Borg.
Bono Borgie. Yeah.
Kim says, hey guys, love your show. The daily path of both comets is plotted on the evening sky map for October 2025. Cheers, Kim.
Yeah.
Thank you, Kim.
Yeah.
Okay, we're going to go up to a Rosanna's fun fact, I guess, next, right?
Okay. Let's see if we can make it work. All right. And this is this week's
Rosanna's Fun Fact.
Well, welcome back, Rosanna, to another absolutely wonderful fun fact. And as usual, Rosanna is always timely with her fun facts, so we'll get right into it. So Rosanna writes, hi, Paul. Today, or perhaps tomorrow, many Canadians will be sitting down together to celebrate Thanksgiving. So I thought I might ponder for a few moments what makes an astronomer's thankful, or perhaps just what makes me, a very amateur astronomer, thankful. It's a big list, but I'll stick to a skyward angle. So let's just, there we go. So as Canadians, our Thanksgiving is more about harvest than a religious event, but in a way, we are sky worshipers. We are lucky to live in a country of freedoms and also a country that may have vast and sometimes inhospitable landscapes, but a country that offers much in dark skies. Although our light pollution is on the rise, we are fighting it. Did you know that Parks Canada protects more dark skies than any other agency or jurisdiction in the world? Pretty cool. Canada's light pollution rate still pales in comparison with the light pollution across the pond. Okay, not Greenland or Iceland, but they aren't really across. They are kind of half over and up a tad. According to a 2016 study, 77% of UK citizens could not see and may never have seen the Milky Way. According to the 2018 study, St. Petersburg was the most light polluted city in the world at the time. Not what I would have guessed. But perhaps even more important than my gratitude to Parks Canada and their partner RASC would be my awe and thankfulness to all astronomers who have gone before for their meticulous notes, their records, and histories, sometimes at great risks to themselves, as not always were the general citizenry of the ruling class of the same page. There was a lot of disbelief. Now, let's see if I can figure out where she starts. Okay, so what we're looking at here from 34,000-year-old ornegation lunar calendar carved on a bone stick to a beautiful German bronze age sky disk that even included a depiction of the Pleiades. Ancient peoples have left artifacts that prove they were keenly aware of the starry realm above their heads. Babylonian star catalogs dating to 1200 BC include Sumerian star names. Greek, Indian, and Islamic astronomy were all grounded in Sumerian discoveries. Egyptian and Arab astronomers were both insightful and knowledgeable. They left a legacy of precise observations, and many of our stars were Arabic names. Make that a little bit bigger. There we go. Just like we are all watching the latest comet news and trying to catch up the latest Swan and Atlas comets, the amount of comet art over many hundreds of years is staggering. I have several tabs devoted to comet art over the ages, and here are a couple of the highlights. So there is this one, and I'll show you those, which are actually quite interesting when you think about how long ago a lot of this was written and drawn and what they were actually seeing. So comets were sometimes called flowers of the sky. If I had to start my star quest from scratch without the aid of everyone who has gone before, I really can't imagine where I would begin. I'm equally humbled, in awe, and inspired by all who have gone before. Although the knowledge and brilliance of some minds can seem overwhelming, there is also the sense of humor that most skywatchers maintain. We can all make mistakes or miss something too. That all too human quality of oops has existed as long as we have. Monsignor Babinette, prenez-vous par la porte de la vista de la comète. That's so funny. Reminds me of what was his name? Doesn't matter. So happy Thanksgiving to all. Now I must go make pies. Pie in the sky. When the moon hits the eye, like a big piece of pie, that's Thanksgiving. And that is this week's
Rosanna's Fun Fact.
Awesome.
That's Rosanna. That was awesome.
Awesome.
Norman Walkwell. That's what that photo reminded me of.
Right. Yeah,
Anyway, isn't that interesting?
it is.
All of that interesting stuff that she always comes up with, and it's always so timely, both on comments and Thanksgiving. So, Rosanna, thank you so much.
Thank you.
That again.
Always very timely and always very the material that she must
Oh,
research
it's
it for.
interesting.
Yeah,
It's so interesting. Absolutely.
where she finds the topics. Amazing. Okay, we got lots of time yet. We're only into half an hour of the show so far, guys.
Oh, wow.
Yeah. I talk too fast, I guess. We can go to photos. We might as well do that anyway. Probably relax a little bit while we're in photos. So just give me a sec. I'm going to do the transition part again here for the
My precious. Oh, wrong photo.
Do the photos in slow motion.
Huh?
Do the photos in slow motion.
Slow motion.
Yeah.
Here's the first.
One.
And it was amazing.
Let me get my share
Thank
screen.
you so much.
Like a popsicle.
We good?
It does. It looks like a popsicle. Nice shot.
This one's from Bonnie Lee Armstrong. She says, "Hello, Chris. I intended to send this earlier and didn't get around to it. This shot is from September the 15th, taken at Waterside, NB.
That's there.
Yeah,
Nice, very nice. Lots of color.
yeah. A 10-minute drive up the bay from Fundy National Park.
Ah,
Always a pleasure to watch the three of you in Rosanna's Fun Facts. So thank you, Bonnie Lee.
Nice shot.
Yeah, not bad at all. I had a lot of Aurora shots. I put up a post because the 10th, of course, was the 1 year anniversary of us being out on the 10th last year.
Right on.
And I had, I don't know, 50 or 60 comments like with pictures of people putting up. It was great. I'd love to see the interaction like that. It's, you know, the people that are commenting back again with their photos, and some are really amazing ones in there.
yeah.
Okay, this one's come from Joey Craswell. Look
Yeah.
at that. Here you go. So
Wow.
Good shot of it, yeah.
this is Comet Lemon. He said, I get up at 4:30 a.m. while camping with the Sea Star S50 to get this image. He said, A6 Lemon's closest approach to Earth is October 21st and may be visible to naked eye at that time. He said, didn't have my computer with me, so this is straight from the Sea Star using its denoise feature.
Wow.
Roughly
Well, you can-
6 minutes, he says, of 20-second images.
Say, nice
Yeah.
shot.
Yeah, you could see the head of it really well, and you can see the separation in the two tails.
The color, yeah.
Starting to spiral in there. That's cool.
Yeah. Nice done.
Well done.
Yeah.
Good job,
Great
Joey.
job. Yep.
Okay, I'm going to go from there to David Samard's captures here. He says,
You're getting so much better.
he is it.
The head of the horse. Look at
Nice
that. Eh?
Horse
answer,
head
man.
right there, yeah.
Yeah.
And we got his version of the the comet
Yeah.
as well.
Sure.
That's quite a long tail on that thing, isn't it?
Yeah, that was a 3-minute exposure, he said, for his.
Still, that's pretty sweet.
Yeah, it is.
And his Andromeda Galaxy.
Found it, yeah.
Nicely done.
Yes, sir.
Good stuff,
never-
David. Keep up the good work, sir.
Yeah, doing really well.
All right, going to go from there over to Mr. Powell's captures here of the moon.
The mineral
last-
moon.
last
The
week.
mineral.
The mineral
That was
moon.
last
yeah.
Yeah.
Yep.
Nice and clear, boy. I couldn't believe how clear it was.
Before we move away from that photo,
Yep.
so are we familiar with what all the different colors are in terms of what their mineral
No,
content is?
I am not.
It'd be interesting to find that out and talk about that sometime. You know, because we see the moon visually as one swath of light down here with the naked eye, but when you shoot it and get those actual colors that are on the surface, it's always so interesting to me, and it'd just be interesting to just to have a chat about what those different colors are.
And somebody actually asked me, how is it you get the colors? And it's pretty simple. The color's there. It's in the shot. All I do is before I process anything else, I bring up the image in GIMP and I stretch the saturation. That's all I do. And the color comes out because it's already there. I'm just stretching it to pull it out. And that was actually, I think a gentleman named Blair McDonald from Halifax did a thing on it. And I remembered that part of it. And that's that's where the color's coming from. It's not, I'm not adding it. I'm not filtering it or anything like that. It's just strictly stretching the saturation.
Yeah, well, yeah, that's what I mean, because they're natural colors. You're not, it's not like a false color where you're adding.
Right.
I've got the list of it right here, actually. So the brownish, the blue area, for example, and there's lots of blues on it, are often richer in titanium-bearing minerals like ilmenite. The oranges and reds are iron oxide minerals. The pinks, and then sometimes you can get some pinks. Actually, I see some pinks in there, close to Tycho, or not Tycho, but what's the crater beyond, just by the Apennine Mountains?
Oh,
Down below, right there.
Copernicus.
Yeah. So if you look to the left of Copernicus, there's some orange in there. Anyway, those are hues can indicate regions of iron oxide minerals. The pinks suggest areas rich in aluminum feldspars, and the purples, which we see lots of, small purple patches can indicate pyroelastic deposits formed by explosive volcanic eruptions. Yeah, so there is a little explanation of what some of those things are, because we don't see a lot of that. And every time Mike shows me, I'm always so impressed to see it. I tried to get it a couple of times, but I can never get it like he does. And so it's just interesting to see what those are. And rather than just looking at the craters, what are the actual minerals and on the moon, which is a topic we don't talk about a lot. So
The moon's fascinating. Just love looking at the moon.
Never get old.
No, Mark says, don't you have to stack the moon images for mineral moon?
You don't have to stack them from mineral. The mineral part comes. I do stack. That's just to get the clarity.
Yeah.
So my process is I take my images, I put them in PIP, PIPP, which is and I use that to center them all. So now when I go to stack them, every photo is centered. Put them into auto stacker and stack it. And then when it comes out of auto stacker, I move it into GIMP because that's my processing software. The first move I make in GIMP is to press the saturation up.
Okay.
Before I do anything else. And I found if I tried doing anything else like lightening it or darkening it before, the saturation doesn't work right. It's going to be the first thing I do once I move it out of auto stacker into GIMP is stretch the saturation. That's what works for me.
Yeah.
So if you took just a single frame and did the same thing, would you still get the color?
You start to get color, but it wouldn't be as much. You know, like anything else, the more you stack, the more you're going to get.
Yeah.
So, but I have pushed it on a single photo and got color out of it. Yes.
Yeah. Yeah.
Cool.
Yeah. No. Anyway, nice work.
Nice work.
Nice. The clarity, the colors they're not overly saturated. It's just a really nice image.
It's fun to try. You know, it's fun to play with. It's
Yeah.
You know, the moon's not just gray.
No, absolutely.
Mark says part of Wilma of the moon is visible. Now I keep forgetting where she is. Oh,
And there's somewhere.
Bring up a picture, yeah.
I still have yet to see this man on the moon. So hey, I've been told ever since I was a kid, there's a man on the moon. Other than the astronauts from Apollo, I can't find him.
There's your original image without the.
Well, that's why I just take it and
stretched.
I stretch the saturation the other way. Just take all the color out of it.
Yeah. Just go monochrome.
Nice other way.
It's kind of neat when you start looking at some of the detail, like the Apennine mountain range and stuff. The color seems to bring it out even more for some reason. Some of the things just seem to pop a little better in color than they do in black and white or in mono.
Yeah, I've been watching lately a few people posting on, using really long telescopes and just getting right into craters and the detail that's coming out lately, just unbelievable.
That's tweaked my interest, trust me.
Yeah.
Get the big guns out and do some shots.
But. Yeah. Oh, very nice.
Awesome, Mike. Still looking for Wilma there. Yeah, I know she's there.
Anyway.
Okay. Let's go to what else we got? Oh, we got your shot of Comet Lemon there too, Mike.
Well, that's the area it was in. I spent probably an hour trying to find it, and that was actually it. I just didn't realize it when I pushed the image up, and I finally saw some green there. I went, ooh! So then I swapped lenses and took a 2.5 second shot and got it.
Oh, there you go.
I couldn't see it in binoculars. I looked and looked and looked. I figured I'd try to photograph and see if I could spot it in a photograph, and then once I did, I knew where to look.
We'll get treated to that next week, hopefully.
Let's hope. Yeah. Well, yeah. I mean, new moon sky is going to make a whole lot of difference, I think, for us too.
Yeah.
Genesis 777. Hi guys, decided to drop in on the show. Welcome. And
Who was it?
Genesis 777.
Oh, Oh, hey, how you doing, Genesis?
And Enviromad. Good morning from Australia. Hey, good morning.
Hey.
Good evening.
Yeah,
Good
I guess
evening and good day. Yeah.
they're into their spring and we're into our fall.
So, is our computer screen upside down there?
I'm falling.
Let us know. All right. Go from there to here's
nice
Benoit's capture of Neptune. Yeah, with his Sea Star S50.
Yeah.
He said, "Cannot believe it myself." Yeah, I mean that's a tough one.
It is.
It is. It does. I mean, it does look soft like that in a telescope too.
Yeah.
A lot smaller, but it's very soft like that. You can tell it's
So
not
here's
that
the
small star.
question.
Hmm.
So which would I think it was either it was Neptune, maybe or was it Uranus? I can't remember, but you could see phases from that planet, even though it's on the outer part. It's like they're outer planets, right? So that's something else to be interesting to find out. I'm going to do a little research and find out about which ones you can and cannot see phases on, because you can obviously on Venus.
Hmm.
You can't on Mars. I don't think. I don't remember that. Maybe you can, but I don't think I remember seeing any.
I always thought that you could see crescents on the inner planets from us.
That's it. And the ones
And
that you can't.
all
Well,
full.
I saw one. I don't know. I'm gonna see if this wasn't maybe fake news. But I saw somebody post one the other day. It was one of the outer planets, and it appeared to have a phase, which I
Wow.
can't see because our sun is ahead of us,
Yeah.
and we're not looking into the sun. We're looking the other way. So, anyway,
Yeah, that would be sunlight reflecting back at you with full face of the sun. So I don't see how it could be.
Well, neither, but then we
anyway,
find out.
I'll look it up and see if it was true or not.
Okay. I mean, what? True? Not true?
True or not true?
On the internet? Okay,
It's
let's
with-
go from.
It's so in the National Enquirer. So.
Here's Kathy Adams' capture of the Eastern Veil Nebula.
Oh, look
I
at that.
love that one. Love that
Veil.
one.
Very nice.
That is so
Very
cool.
nice.
Hmm. The Eastern Veil Nebula is the large supernova remnant in the constellation of.
Cygnus.
There we go. It's an expanding cloud created by the death of an exploded star. Added a third night of data, so approximately 6.5 hours now of integration time with my
There
Dwarf
you
3, with her Dwarf 3. Stacked and processed in Serial and Photoshop.
That's there.
30-second exposures and 60 gain. Having fun seeing the difference additional data makes. So.
Well, there you go. You know, it's funny that I'm glad she posted and talked about that because, if you're taking a 10-second image and you got, I don't know, 400 10-second images, how much time do you have?
Right.
Right? It's next to nothing.
Hmm.
So when you shoot what she shot here, and I can just by looking at it, I can tell that she's got a lot of time on the target because of the detail. If you look at the bluer regions, which would be the O3 regions of that, can you blow that up at all?
Yeah, I can.
So if you look at those bluer regions, you can really see a lot of detail, a lot of finite, almost like little hairlines and stuff in there.
Hmm.
And you don't get that from really quick, images. You got to spend a lot of time to get that kind of detail. And even though that scope that she has, I think it's a 35 millimeter. I could be wrong.
Yeah.
But in any event, you can get a fair bit of detail, but it's just all about gathering light, eh?
Hmm.
And that's proof in the pudding right there.
Yep.
Really nice job.
Nice job. Oh, Genesis 777 said it's Francois Dariel, your local astrophotographer. Hey, Francois.
Oh, that's who that is. Oh, okay.
Yeah, that's who it is. Yeah.
Great. Anyway, nice job.
Yeah.
Paul. Very
nice
nice.
job for sure. Okay, let's go to this one here. Is another one of hers as well. The Andromeda Galaxy
There you
M31, it's
go.
smaller M32. So, yeah, I assume it's with the same scope.
Stuff never gets old.
Hmm.
No, it doesn't.
Look at the dust clouds in there, man. That's fascinating.
Yeah.
That picture of the gigapixels of Andromeda, I think it's called, and you can zoom right into the dust
Oh.
lanes. And
Yeah.
it's amazing. Yeah, 1
Yeah.
trillion suns. 1 trillion suns. Yeah.
Yeah. That's the nice thing about the small scopes too. Like when you got like Mike and I both got 60 millimeter telescopes, is you can fit a lot of stuff in the screen, especially if you got a little bit larger chip camera. You can fit a lot of stuff. Wide field is so beautiful now.
Yeah, absolutely. All right, Kathy. This one's from Mr. Mark Ficken.
Nice.
SRS-30. Today's sun.
Let's hope that dark spot opens up towards us.
Right in there,
Yeah, exactly.
Well, not this week. We want it next week.
No, true.
Well, maybe this week, but who knows? But
Well, hopefully there'll be a bigger one coming around.
there you go. It's still been pretty active. Like we've got a lot
They're
of
still spread out. Like you
Yeah.
see some tops out in the middle and then one down near the bottom on the side.
Right.
They're still spread out pretty far. They're not coming quite together.
Yeah.
Oh.
I would have
Yeah.
expected it to settle
Oh.
down by now, but anyway, great stuff, Mark.
Yes, indeed.
That'll take about 5 years to settle out.
This one from
Wow.
Mr. Owen. Yeah, look at that, Mr. Owen.
Oh, look at that. Doggy.
What do you say there? It's been so long since I've done this astrophotography, you say. I took out a tiny 61mm doublet and tried capturing M31, the Andromeda Galaxy. I realized that after this I needed plenty of refreshing, but a good first attempt in a while. I forgot how much I liked being under the stars on a clear night. There you go, Paul.
Yeah, there you are.
Yeah,
That was with the 294, you said?
Yeah.
That was your 294?
Yeah, that was the 294. If you zoom in on it just a little bit, I don't know how much this JPEG is going to show, but you can see. Okay, good. That's good. You can actually see some of the red hydrogen alpha pockets all around the rim.
Yeah, the dust.
Really nice. So of course that's where the star forming is, and all kinds of those star pockets, those blue clustery areas.
Yeah.
Absolutely wonderful to look at. And then if you look at the core right into the center, a lot of people think it's actually just you can't really see much. But if you can actually process it correctly, but you have to have a fair bit of not a fair bit, but some aperture anyway, and you can see all of the stars in and around.
Say you did a nice job on the core. That's nice.
Yeah, and so that's actually what's in the center of it. But when we look at a lot of photos, because it's a really hard thing to get, because it's so bright. I mean, it's naked eye.
Yeah.
So if you have, and this was a minute and 80, no, 3 minutes sub, and I was able to get that core control, which was really, really hard to do. But anyway, it turned out pretty good for the little tiny telescope. And I think next week I'm going to talk about the ASI Air.
Yeah.
I've had one for over 2 years. I've never used it because I found it too complicated. And here I am running an observatory with all the junk that I run. And I found that so hard to do. But I kind of figured out. And I would like to compare it, both what the experience is like using that versus using all the outboard gear that Mike and I use, and also what it's like to be under the stars again, as opposed to being in a room in front of a computer when you're letting your telescope in the observatory take care of that. So I just kind of want to go over those two things and have a chat about that.
Awesome.
But this inspired me to do that. So
yeah, awesome, great capture, Paul.
Yeah, thanks.
Nicely done. And this one. I had to sneak that one in.
That's hilarious. I got to tell you the story. Did you get any other pictures besides this one?
Just that one.
Okay.
That was the prime shot, so I had to take that one.
All right, so I got to tell the story along this. I got a call. They wanted me to photograph. This would be my fourth one now. This event called Witches on the Water, where they take all these witches and they go out and they get on paddle boards and all that stuff, and they just go around, and there's a whole bunch of them. And so I said I don't want to do it from the shore because you won't need me, because everybody's going to be taken from the shore. You get all the pictures you want. I said, but I need to get out in the water in order to be able to give you decent photos of these witches. So anyway, so they put me in this little paddle boat. If you look on the other side of it, there's blue weights in it so that it doesn't flip and tilt too much. Yeah. And that's my first time ever on one of those things. And I got to tell you, it's a hard thing to paddle.
Oh, I wish I had forgot those weights.
All these little witches. So yeah, there's a few pictures like that kicking around, so that's funny. But you know what? A photographer always gets the picture no matter what, right?
That's right. do what you got to do. Yep.
You gotta do what you gotta do. Oh, that's funny.
Awesome. All right. Well, if you have images that you would like to share, send them in to astronomybythebay@gmail.com, including you, Francois, because I have to keep going hunting for your pictures. So send them in to astronomybythebay@gmail.com, and we'll be happy to put them up on our next broadcast. Okay. Something I wanted to mention. Tim Doucette, who's our friend down in Nova Scotia. Tim runs the Deep Sky Eye Observatory. Tim asked me if I could share this, wondering if you might have time to plug the following on your show. It's our main event is the Starlight Gala uh, with guest speaker Stefan Picard from Cliff Valley Astronomy. And there's a star party at Deep Sky Eye as well, unveiling the largest telescope east of Montreal, a 25-inch Dob. So
Wow.
there you go, yeah. So if you want to find information about this, just go to starlightfestival.ca and drop in, because that would be love. I'd love to go down for that myself. But,
Oh yeah. 25-inch Dob. Can you imagine?
Wow.
I think the 20-inch is about the largest we've had at one of the star parties, isn't it?
I think so, yeah. Maybe one of you guys could bring up that site, starlightfestival.ca, would you, for a second?
Yeah, I'll look for it.
I can't open it up here.
Starlight Gala. Is that what it's called? Starlight Gala 2025?
It's called starlightfestival.ca. Go there.
Okay.
And I'm going to stop sharing. And I'm going to let Paul share. Just quickly.
Starlight Festival. I think this is the one. Starlight Astrotourism Rockville. Starlight Festival. Is this the right one? Nova Scotia. Yep, that's it.
Yep.
Okay, I'll just share my screen here. Hang
Yep.
on. Where's the share on this thing? There it is. So hopefully this is the right one. And it looks like it. So this is the Starlight Development Society. And all kinds of things about astrotourism, the festivals, responsible lighting. And so this tells you a little bit about what it is. And it's in southwestern Nova Scotia. Promises to be a fantastic celebration of the mesmerizing night sky from October the 12th to the 25th. So it's a long event. And this 2-week festival will showcase an array of exciting space-themed activities, products, and services that will captivate the interest of people of all ages. Don't miss out on this unforgettable opportunity. And so there's all kinds of things that'll be going on: cell phone astrophotography, stargazing at with Deep Sky Eye. Anyway, there's a lot of things going on. So that is the site right there, Nova Scotia starlight.com, Starlight Festival, and it'll come right up.
Yep.
And then you'll be able to go through that site and check out what's going to be going on down there.
Thanks, Paul.
All right.
Okay, I'm going to just one more second because I got 2 more slides to share, which I normally do. Oh, hang on. Bear with me just a second, folks. Where did my... I want that. I want this one. Screen. This one. Here. Okay, yeah, so just the last couple of slides that we try to share normally each week. The September-October calendar here that you can get from sjastronomy.ca. Just go there, download the calendar. This is the 6-week calendar that Kurt Nason puts out for us. Probably pretty well due for another one here pretty soon.
I just got it today.
You did? Okay, there you go.
It'll be up tomorrow.
There, and there's a couple of double shadow transits, I think, coming up too. This week coming up. Well, we might miss this one, but anyway, you can find the calendar at sjastronomy.ca, and I don't know if it's on RASCNB or not, but you can find it for sure here. So download that to give you the idea of what's happening throughout the month. And also we have Lisa's Lookup. Lisa gave me this new chart for October just a few days ago. So she's reminding me now, keep an eye on Saturn's rings this month. And keep an eye out for the Comets lemon and so on. So Lisa gives us this calendar every month. You can go to her site at Lisa's Lookup, Astronomy and More. And she gives us the event itself, the date of the event, the peak time, and what you need for seeing tools, naked eye, binoculars, or a telescope. You can find Lisa at Ruby Moonbeams on Instagram, Mastodon, Facebook, Threads, and now on Blue Sky. There we go. So thank you, Lisa. And I'm going to log out of this one. And we're going now. Probably going to sign out here pretty soon.
Yeah, 3 minutes.
Oh yeah.
Not yet? Okay, well, hang on.
We played it out pretty long.
Yeah, okay.
What you needed was a longer comment tail. See?
That's what we needed, yeah.
We're taking up the extra 3 minutes.
So remember now, next week Paul's going to be talking about the ASI Air and its advantages and how to use it, and comparing that to actually getting out underneath the sky and observing it.
Yeah, well, it's not going to be a tutorial. It's just going to be in my experience with it. and comparing that with using the observatory.
Okay.
Yeah.
All right. So in closing then tonight, thank you all for joining us again this evening, and all the extra guests that have been on here with us. Special thanks again goes out to Rosanna, of course, for her continued contribution. Rosanna, thank you as always. Really appreciate it. Also, special thanks to all of you who share our program out there. We really do appreciate it. And remember, too, we do love getting your photos, so send them into astronomybythebay@gmail.com, and we'll be happy to put them up in our next broadcast. If you have an idea for a topic for another show, please let us know at the same address, because we'd like to get your ideas. And we run out of them after 6 years, so really. And please let your friends and family know, too, that we will be here next Sunday evening at 8 p.m. on YouTube and Facebook to entertain you on
So
astronomy.
I almost questioned that for a second. See,
Got all that in. To entertain you on the astronomy and the wonders of the night sky. So for now then, from Mike, Paul, Rosanna, and I, we all wish you a very safe and happy week. Clear skies, maybe. Let's hope. As we like to
happy
say, guys,
Thanksgiving.
that too. As we like to say, open your eyes to view the skies and keep your scopes pointed up. Good night, everybody.
Right.
I'm FBI.